So welcome everybody to the Python data visualization with Python 2 workshop. This morning we'll be talking about making interactive plots and widgets. The link that I've shared with you is a link to a GitHub page where I've stored all of the materials that we'll be working with this morning. I'm going to hide my video controls just so that they don't interfere with my web browser. All right, I think I'm set now. So on this GitHub repository page, I've included two links at the bottom, which you're welcome to click on if you'd like to interact with the notebooks as I go through them. One will take you to a Jupyter Hub that I host at IDRI here at UCLA. So it will require you to authenticate with authentication with UCLA. I'm going to select that one. For those of you who don't want to use that or aren't necessarily affiliated with UCLA, you're welcome to click on the Launch Finder link, and that will take you into a similar environment. So when you click on the launch into to the Jupyter Hub, you'll click on the orange button to log in. That will then require that you select an identity provider. You can select either UCLA, which will then take you to the UCLA sign-in page, or you can select Google and sign in with your g.ucla.edu email. I'm going to choose Google just because that's where I've been working with the files. So once you get authenticated, you should see this blue scroll bar scroll across. Then the materials from the GitHub repository will be cloned directly into your account. And you should be launched into a folder that's has the same name as the GitHub repository that that I was showing you. I'm going to pause just very shortly here to make sure that people are logged in if they want to, and if you have any trouble, please feel free to let me know now so we can address any login issues. All right, I'm going to assume that everybody's okay. For those of you who haven't worked with Jupyter before, these files, which have the .ipynb files, are Jupyter notebooks. You can open them by simply clicking on the file name. I'm going to open up the very first one, which is 01-ipywidgets. This is the first notebook that we're going to be interacting with. And clicking on the file name will take you into a separate browser tab, which has the title here, ipywidgets. In order to run things inside of the Jupyter notebook, you can either hit Shift and return. That will execute a cell. And by cell, I mean this thing, which is highlighted by the bounding bar. There's also a run icon at the top, or you can come under the cell menu where there are a variety of options for running cells. All of the code, I've already provided all of the code that we're going to be working with, so you won't necessarily have to type into any of these cells until we get to the exercises. I've included a couple brief exercises. So to type code into a cell, you would select the cell that you want to interact with. The ones that are code cells are the ones that have the grayish background and have the in text to the left of them. When you see the blinking cursor, you can type into the cell, and then you can do Shift and return to execute the cell. All of the code that I'll be showing inside of the code cells is Python 3 code, which I'm going to assume that all of you are familiar with Python. Or if you're not familiar, hopefully you'll get at least a sense of what it is that I'm doing just by seeing what happens when I execute the cells. The first library that we're going to be talking about this morning is the ipywidgets Python library. So if you attended my workshop, so there's a question in the chat, is ipywidgets available with a generic Python distribution? No, it's not. It does have to be installed. So the Jupyter Hub environment that you're accessing, I've already installed IPyWidgets, and I've already installed all of the other libraries that we're going to be interacting with. IPyWidgets, this comes from the documentation for the IPyWidgets library, which I'll paste here in the chat. So the IPyWidgets library is for creating widgets. And widgets, here is a description, are eventful Python objects that have a representation in the browser, often as a control like a slider, text box, or etc. So they're really intended for introducing interactive elements into Jupyter notebooks. You'll get more of a sense of that when we work here through the Jupyter notebook. But essentially, they allow you to combine Python with JavaScript elements, which are rendered on your web page. So I won't necessarily go through what a Jupyter notebook is, but the Jupyter notebook itself is a JSON file. It's kind of responsible for rendering everything that you see on the front end through your web browser. And then it communicates on the back end with something called a kernel. And the kernel is what executes the actual Python code that you execute in the cells. So there's communication between the front end that you see in your browser and the kernel on the back end, which is executing the Python. Whenever you execute a cell, the front end then communicates with the kernel, which executes the code and then returns the output back to the front end. There are various JavaScript things that get incorporated into the notebook on the front end. So the widget, which we're going to see examples of in just a moment, communicates back and forth with the kernel in order to execute the code. But the widgets itself incorporate JavaScript into how they're rendered on the front end so that it builds in that JavaScript interactivity into interacting with the code. The first thing we have to do is simply import the IPyWidgets library. This is the name of the library. And then I'm going to define a very simple function, f. All that the f function does is it returns the input parameter that you pass into it. So there's dynamic typing in Python. You can call this function with a range of different things. If I call it with an integer 10, it just returns the integer 10. I can call it with a string. Here, Python is the notebook. You know, there's no explicit print here. This is kind of just a feature of the notebook in that despite the fact that I don't have any explicit print statement here, what gets put into the outputs part of the cell when you execute a cell is just what's getting returned here from the function. So here now, I'm going to introduce the widget. The one example of creating a widget is simply to put the name of the IPyWidgets library and then call a function from that library. In this case, it's the function called interact. And then the input parameters that you pass to it, the first input parameter has to be the function name. And then subsequent parameters can be the variable name that's called for the function. And in this case, I'm going to pass it an explicit value of 10. And what happens when I execute this? By default, the interact function creates this slider. So you can actually come here and in your notebook, if you're executing this yourself, and right now I'm selecting the this dot with my trackpad on my laptop, and I'm explicitly dragging it to the left and to the right. You can see the slider is labeled with the variable name. It shows you what the value is for the slider. So the slider itself has a value. And then it's also printing out 10 because that's what happens when you call the function f. So interact itself has some default behaviors. If you pass in parameter values that are integers, by default, it creates this integer slider. So you'll notice that all of the values that it's scrolling between are integers. If I come down to the next cell and execute that instead, so maybe I'll make my screen a little bit bigger font. And I execute it with a Boolean value. It assumes by default that maybe what I want is a checkbox, like a true or false. So checked, you can see the f function just returns the value that's passed into it. In this case, it's true. If I unselect it, that's the false. So it simply toggles back between true and false depending on whether the little checkbox is checked or not. And then you might be getting the hang of this now. So if I pass in a float, something with a decimal point, now it's not going to be an integer slider, it's going to be a float slider. So when I scroll between the different values, it goes in increments of 0.1 instead of going in integer increments. So another default value, I'm going to execute this again. By default, the slider is assigned the value that you pass into it in the function. And it scrolls between that value and negative of that value on the bottom end and a maximum of 3 times that value, just so that it creates an equal range here for the slider. I'll come in just a bit to how you can be a little bit more explicit about kind of the characteristics of the slider that you're creating. This next example is just to show you, it doesn't just have to be one parameter. You can create multiple sliders at once. So H now has 2 input parameters and returns both of them. And now when I call the interact function, I call it with the H. H is the name of the function. And then I pass in the first parameter, which is P. I assign it to 6, and then I assign Q to 5. So now it creates 2 sliders. Both of these are going to be integer sliders because I've passed in integer values to the parameters in the interact function. And they're both going to scroll between, in this case, between -6 and 18. And you can see when I scroll this, it changes what's being returned by the function. And I can scroll Q as well. So there's the ability to scroll these independently of each other. You can be a little bit more explicit about what particular widget is generated by explicitly saying, like, for example, that you want the integer slider. So the IPyWidgets library, whose name is here IPyWidgets, has a variety of different slider functions that you can call. The inSlider just creates an integer slider, just like what's illustrated here. So now this is the same function, but now I'm explicitly passing in for Q. For Q, I'm passing in an integer slider as its value. So you don't have to pass in a number, say, or a string or a Boolean or any variable like that. You can actually pass in one of these slider objects into the parameters. And when I execute this now, I can more explicitly specify, say, what I want the min to be, the max, the step, which is how much it increments when I, right now I'm pressing the left and right arrow on my keyboard. So this is the step when you scroll the integer through its values. And then value here is just the starting value for the widget. And there's a shorthand for this as well. If you don't want to explicitly specify the slider, you just want to have a min and a max and a starting value, you can pass that in as a tuple to the parameter. So in this case, it goes between 0 and 100 in increments of 5. This is the step, I'm sorry, it's not the starting value. So I've illustrated this with integers. It's very straightforward to do it, say, for floats or booleans. Instead, just by passing in different things into the input parameters for the function. Now I'm going to pass in a list. And what happens when you pass in a list? It doesn't create a slider or a checkbox, it creates a drop-down menu. So in this drop-down menu now, you can select between apples and oranges in this case. It's just a 2-element list. And it assumes that the values that this particular widget object returns are just the strings that are a part of this list. So when I change values inside of this dropdown, it returns this part, or what it uses this as the input parameter for the f function. And then f just returns what it's passed in. So now it's returning the apple string. So I think that I saw that somebody had their hand raised. Does someone have a question?
Yeah, hi Benjamin. Quick question. I'm practicing as you are talking. I would like to change that name X equal to apples and oranges. Instead of X, I'm trying to give it as name, and it's throwing me some error. How do I change X to something like name, or so like a question? Choose the product, something like that. Yeah.
Yes. Yeah, so it has to match what's in your function definition. So if I come back up here and I change f to name here and return name, and then when I come back down here to this, now name is the input.
Oh, got it. All right, perfect. Thank you.
You're welcome. So in addition to having this drop-down menu where you specify the label that's included here in the drop-down menu, you can have other values. Say that you want apples, not to pass the input parameter apples to the function f, but you want apples to represent the number 10, say, and the string oranges to represent the number 20. You can do that by passing in a list which has tuple elements. The first one is the label that will be put into the drop-down menu, and the second is the value that will be used as the input parameter for the function. Oh, and now here, since I've changed X to name, I'll just change this to name. So you'll see when I change it to oranges, now it's echoing 20 here because 20 is the value that's passed into the f function when I select oranges for the drop-down menu. It is possible to explicitly get the the values and the keywords that are being used inside of these widget objects. To illustrate this, I'm just going to define a different function f, which is explicitly going to display the sum of the number, and it's going to return the sum of the number. So now, instead of calling the interact function, I'm going to call interactive, and I'm going to assign it to the variable w. A and b for the function f are both integers. So by default, this is still going to create integer sliders for a and b. When I assign it to a variable now, it doesn't actually output anything explicitly from executing the cell. But if I type w just by itself inside of the notebook, I can get it back. And it behaves, similarly to what you might expect from above. So when I vary the slider, it varies by integer values for both a and b. And now it's displaying the sum of the numbers rather than just a single number. If I'm a little more explicit about what w is, the type function will return the explicit type for w. So w is this interactive IPy widgets object. And there are actually a couple different layers here. Ultimately, you can think of w just like a widget object. It has certain attributes to it. So the children are the explicit things that are included here in the output. So the first one is the integer slider. This is kind of like what I explicitly designated above in this, when I assigned the integer object to one of the input parameters. So the children of W, there's an integer slider for A, which is this first child that's called. There's a second integer slider. This one is for B. And then there's output. And this output is another specific object that you get from the IPyWidgets library. So you can be a little bit more specific about the output that's generated and what it is you do with the output space, which is really handy when you want to try and exert a little more control over the what's being generated when you alter the values that are inside of these widget objects. If there's another attribute, the KW-args, the keyword arguments. So this is a way to get the values that the sliders are currently set at. You'll see this doesn't return the initial values here of 10 and 20. This actually returns 4 and 29, which is the values of the sliders as they're currently set. So this widget object kind of maintains an identity as I'm going through the notebook itself. If I change this, say the value of A to 22, and I come back and I look at what this is now, it's changed to 22. So these maintain their identity, and I can use the values that they have at later points in the notebook if I want to. And just by kind of explicitly getting information from the widget object, which here is W. Result is what's returned by the function here when I call the function that's passed into W, which here is this one, which returns the sum. One final thing before we start getting a little bit more into data visualization, which is our main topic. I've created a function here, which is just intended to be somewhat on the slow side. So it has a single parameter, and then if you pass in a very large number into this function, it generates a very large list, and it takes a certain amount of time to actually calculate the elements in this list. So I've intended for it to be slow just so I can show you some things about manually executing the widgets. The ones that I showed you up here, as soon as I slid this, you can see there's, the output is instantaneously changing as I'm changing the position of the slider. You can imagine if the function itself was slow and I was trying to vary this relatively quickly, the response time between your output and what you're passing into it with the input value that it gets from the slider there might be a certain delay. If it's really slow, there might be a significant lag for it. So in order to accommodate that, you can make some accommodations. This first one, here I'm just making the slider just like I did above. So I'll get this on one screen here. Slow function is the name of the function, and then it's creating a float slider with a minimum of 100,000 and a maximum of 10 million with a step size of 100,000. So now if I go really fast on this slider, there's definitely some delay here. It's probably still going to be delayed here, waiting until it gets to so I put in 5.4 million, which it got to now. One option for kind of getting rid of that lag and allowing the user to settle down on the value that they want for a slider without having to worry about the output immediately being generated is that you can generate an explicit run button. Here, this is a different function. It's not interact, it's interact_manual. And with this now, I can vary the value of the slider by dragging it around, and it's not actually going to explicitly call the function until I hit the run button. Otherwise, the slider activity is exactly the same. So here's 5.4 million. And then when I click on that button, then it calls the function, you know, and you don't have to worry about all of the lag when you're going in between different values. It just tries to run the function for the specific slider value that you set before you hit the run. And then here is another thing that you can do. Rather than putting in the run button, you can put in an additional parameter into, this is inside of the parameter values for the slider. So if you say continuous update equals false, that's a way to tell it if I'm in the process of varying this, don't call the function until I explicitly stop. So then it doesn't try to do intermediate values as you're dragging the slider. This might be a little hard to notice at the moment, but certainly when you generate plots and data visualizations, it can take a long time to render the graphic. So something like this can be very useful. Say, if it takes a long time to render the graphic and you try and say, vary the value of the slider, you don't want the graphic to be rendered for every single value that you're sliding through. You only want it to be generated for the one that you settle on at the end before it actually tries to render the graphic. So that's just a usability feature. So now for those of you who are following along, I'd like you to try and just make this interact function yourself. So I've included a cell here. I'll execute this myself too. So what the cell does is it takes a string as input and it prints out the reversed, the string in reverse order. So I'll give you a minute here. Just try and make an interact function that calls this with a string so that then you have an interactive control as a widget object for this function. There's a question. Could you tell us how to extract these plots to PDF or Excel? Do you mean the graphics that we're going to be making later, or something like the notebook itself? Sure. So I'll along the way I'll try and show you how to export the graphics. Or if I don't remember to, certainly ask me after the class too, and I can show you how to do that. So hopefully you've all finished. Unfortunately, in this virtual environment, I can't really see how everyone is doing, but I'll assume you've gotten through it, or I've included a cell 2, which you can execute. This %load is a Python magic command, which will load the content of this Python script directly into this cell. This was my solution now. So the load loads it and then comments out the load magic. If I execute this, so I tried ipywidgets.interact, reverse is the name of the function, and then I passed in a string to the X parameter. So when I say, hello, my name is Ben, it prints that out in reverse order. So now we'll get to data visualization more explicitly. There's another question. I'm curious how easy it would be to use ipywidgets outside of Jupyter, for example, in PyCharm. That's a good question. And I'm not exactly sure. My sense is that, or in a terminal with X forwarding, the question continues. Certainly in the, I think it's explicitly built into the machinery of the Jupyter Notebook, but I can't say that explicitly because I haven't tried to use the ipywidgets library somewhere else. But worth exploring, I think, because it is a very useful library. So back to the data visualization, I'm going to take, I'm going to generate a plot with matplotlib. So for those of you who came last week, we kind of covered this basic syntax of matplotlib. I'm going to look at the Gaussian distribution function. So this is an exponential function. It has two main parameters, the mean of the distribution and the standard deviation. So say you're teaching a class in statistics, and you want to plot this function for your students, but you also want to give them a good sense conceptually of what the mean and the standard deviation are, which are very fundamental concepts in statistics. The first cell I'm going to execute in this section is just importing the libraries. PLT is going to be for plotting with matplotlib, and I'm going to use NumPy to generate just basic numerical arrays. In the next cell, I explicitly set a value for mu, a value for sigma. Then I specify my X and Y. Linspace generates, this is generating a NumPy array from -10 to 10 with 200 points. This is the specification for the Gaussian distribution function. So I set that to my Y values. And then I use this for plotting. I'm going to assume for the moment that I don't need to cover a lot of plotting explicitly with matplotlib. I can cover that later after the course if anybody has any specific questions about the plotting. But what this does is it generates a plot of the Gaussian distribution function here. So now what we can do, say you want to visualize this with different values for the mean and the standard deviation. One is just to explicitly put that code from above, which is this highlighted selection, put it into a function where you can specify as input parameters the mean and the standard deviation, which here is mu and sigma. So when I execute the cell that defines the function, when I call the function with a explicit value of mu and sigma, it generates the plot for me. So, I could come to this plot, I could say, what happens when I change the mean to 2? Well, it shifts it to the right so that the peak of the distribution now is over 2. or if I change the standard deviation to 3, it makes it wider. And kind of another feature that you can see here. So this is a normalized distribution function. So the total area under the curve is equal to 1. So when I make it wider, the peak gets lower. You know, there are a number of illustrative concepts that you can see when you're trying to make a plot like this. There's a question, is there any way to set interact so you can input the X instead of using a slider? So yes, and the question continues kind of like what you did with the reverse string function. So yes, so to address that question, up here, when, for example, I said this, I explicitly set one of the parameters to be an integer slider. Instead of specifying it to be an integer slider, you specify it. You can specify it to be something like a text box that accepts a float and returns the float that you type into the box. So in order to look at the different objects, actually what I'd recommend is that you come to the IPyWidgets documentation. And it lists all of the different widgets that you can have. So like here's the integer slider, there's a float slider. You can have kind of a range of sliders. Here's where you have the, you can have a bounded int or a bounded float, or just an int text and a float text. So instead of int slider, you can specify, say, int text or float text, and then you'll have a box that you can type into. Perhaps I could illustrate that with my next example too. So here what I'm illustrating is, you know, it's definitely handy to be able to enter different parameters into the function call, say, and generate different graphics. But you have to keep on going back and forth to the function and re-executing things. Putting in an interactive widget makes this process a little more conceptually easy to access because you can vary things so quickly. So here now I'm calling the interactive function for the IPyWidgets library, and I'm passing in the name of the function which generates the plot, which is Gaussian. And then mu and sigma are my two input parameters. So now when I vary these, you know, it's a little more accessible as to what, how the graphic changes when you vary different parameters. For the Gaussian distribution, statistically, this is a very important function, although, you know, it's might not necessarily be complex once you really grasp the fundamentals. I'm sure many of you in your research might have come across complicated functions or models that are dependent on different variables in very complex ways. So making a slider like this that you can vary, kind of instantaneously see how the graphic varies as you vary a certain parameter can be a very useful tool when you're trying to conceptualize the dependency of something on some other variables. And just to kind of play this up a little bit, for those of you who want to play a little bit more with the matplotlib code itself, this generates, you can come back and look at this if you'd like, more explicitly sets what the ticks are, what the labels are, the text that you add to the graphic, you know, itself can vary when you vary the values of these parameters. So now I change the mean to -2. Say I'll change the standard deviation to 2 as well. So you can explicitly see, say, how the half width at half max changes. You can add lines to it. There are a variety of things that you can do which make the graphic itself nice, and that also varies when you change the values of the sliders or other widgets that you have. So I've included a function here for you to try this out with. this function just generates a sine curve. It plots sine of kx plus p. And so k determines the wave number for the sine wave. P is the phase. And this plots it for certain values. So try and use the interact function now to vary, to explicitly vary k between 0.5 and 2, and to vary p between 0 and 2 pi. All right, I'll come back now. And I'll show you my solution. So I took the function, which was here defined as plot f. And I simply called it with the interact. I pass in the name of the function. And then I pass in k and p. For those, I use a tuple 0.5, 2 for k and 0 and 2 pi for p. And when I execute this, now you can see how k, changing k, right, changes what the wavelength is. So k has an inverse relationship with the wavelength. As you increase the k, the wavelength gets shorter. And then as you vary p, here, by the way, you can see what happens when there's a lot of lag between the slider and the graphic. But varying p changes the phase, which kind of translates the wave in the positive or negative direction. And it's still not done, they're finished syncing up. All right, so that's the end of this notebook. If you're following along, I recommend that you explicitly close and halt this notebook just so that there's only a finite amount of memory that's available to each user in this environment. We won't really push the bounds, but just to be on the safe side. Just to orient you, just some of the notebooks that I've included here, my intention is kind of to give you exposure to a variety of different libraries. And so unfortunately, I can't really dive very deeply into any of the libraries by themselves, but I do have the ones that are numbered with a number starting with 0 are the ones that, I hope to cover to some extent today. And then I've included other ones which are called for fun, which I definitely invite you to look over these later. These kind of allow you to explore things in a little more advanced way. I'll just show you quickly here the one for IPy widgets. So this is looking at gradient descent, which is an optimization algorithm that's used in machine learning. I'm going to execute just the first couple of these cells. So gradient descent takes the given function And then you pick a starting value and you try and find what the minimum value is for the function. And there's an algorithm for doing that. I'll show you the widget. This widget is intended to illustrate how the algorithm works and how it might backfire on you if you choose the wrong parameters. So this is the function. I've also plotted on top of it a data point, which is, say, the initial value. And then I've included a couple of things for sliders. Eta is the step size of the step that you'll take between each iteration. Varying the slider for num iters will allow you to go between, to progress in successive steps. X0 is the initial value for the starting point. So you'll see here, if I increase slider, what I'm doing is on top of this plot, I'm plotting additional points for each of the steps, and I'm plotting the little dotted line so you can follow between the different points. You'll see here for these particular values, it kind of gets stuck oscillating about this, although it does make its way eventually down to the bottom. Say I increase the step size, I think maybe that'll help things out. Well, if the step size is too big, you know, it goes to the wrong minimum. We didn't actually find the global minimum of the function. And if I make it smaller, now I can kind of more properly get to the minimum. So this is just an illustration of something that's kind of a little snazzy that you can do with IPy widgets. I'm going to close and help this one as well. And what I'd like to go to next is this one called O2 IPy widgets takes on the Datasaurus. If you haven't ever run across the data set called the Datasaurus, it's a really fascinating data set. So I'll show it to you here. It kind of derives, the motivation for this is derived from a famous data set called Anscombe's Quartet. Anscombe's Quartet, which is illustrated by the plots here, is just a simple set of data points that are plotted here as a scatter plot. There are 4 data sets, one for each of the graphics that's generated. And despite their obvious, you know, differences, all of these values have the same regression line. They have the same mean, they have the same standard deviation, and they have the same correlation between X and Y. So this kind of clearly demonstrates how useful it can be to make a graphic of a data set in order to really, you know, how important it can be to visualize data in addition to just looking at summary statistics. The Datasaurus data set kind of expanded this in a fun way. So it took a scatter plot of a Tyrannosaurus Rex. So you have a mean for all of the X values, and for the Y, the standard deviation for X and Y, and the correlation coefficient between X and Y. And then it used a simulated annealing process to come up with other data sets, which have the same number of points and have all of these same summary statistics, but are clearly different, you know, from a visual standpoint than being a Tyrannosaurus Rex. So all of these data sets have the same summary statistics, but you can see that they, you know, just by eye, you can pick out what the pattern differences are. So we're going to try and work with this data set ourselves. So I've already provided the data set to you. A TSV value is just a tab separated value. I'm going to import the pandas library, and pandas is used to read in the data into a data frame. This is a pandas data frame. So this is what's inside of this file. It gets put into the data frame called DynoDF. There's the kind of the name of the data set. So all of these data sets have a unique name to them. The one called Dyno was just the representation of the Tyrannosaurus Rex. It gives you the X and Y value for each of the points that we're going to plot as the scatter plot. And then if we use matplotlib to plot this, this initially generates the figure object, which has 2 rows and 2 columns. I'm going to assign to X and Y just the X and Y points that match up with the Dino data set. And then I'm going to generate a couple different plots. So I'm going to execute this first and then explain what's being plotted. All right, I'll make this smaller so you can, hopefully the text isn't too small for you to see. But this first one generates the scatter plot, which is this. So we have the picture of the Tyrannosaurus here. The 0, 0 plot is the histogram along X. The 1, 1 plot, which is this one, is a vertical. It's a histogram plotted vertically, which is the Y histogram. And then in this box, I haven't explicitly included a graphic. So I have instead just pasted text on top of what's in this particular part of the plot. So there's the mean and standard deviation for X, mean and standard deviation for Y, and the correlation coefficient. So this now generates a graphic, which we can use to visualize this data set. And then what I'd like you to try and do, kind of to follow up on what we did with the IPyWidgets library, I'd like you to use IPyWidgets to make a menu for cycling through all of the data set values. So this is kind of like our short-term capstone for using IPyWidgets. So I'll give you a couple minutes here. And then for the person in the chat, let me message with you privately. All right, I'm going to come back and assume, hopefully that people have made some headway on this, if not completely finished it. So my solution was to take just exactly the code that I showed here. That's this code, which it's exactly the same, except that I explicitly specified the data set as a parameter and a function definition. So I called my function widgetosaurus. My input parameter is dataset, which has the initial value dino. So that is changed here to dataset instead of being explicitly specified here as dino. And then I have, that's actually the only place that dino showed up in this code. So then I call interact with the name of my function, and dataset is my parameter, and to dataset, I pass in a list, dinodf.dataset.unique. In fact, I should have included a hint for this for those of you who are not as familiar with pandas. But this gets dinodf just by itself .dataset gives you a series of all of essentially that column called dataset. That this is the data frame. Dataset is the name of the column. If I call unique, this gives me a list with all of the unique values. So this list now, I pass into the dataset input parameter. That's the list that then is used to generate the values that are inside of this drop-down menu. So now I have a drop-down menu. The default value is dino, which is my default value for the function. And then I can change this to any of these different data sets. It changes the scatter plot, it changes the two histograms. And you might notice it's hard to tell whether or not it's actually changing the value of the text values because essentially they stay the same. But you'll notice kind of a number here in the hundredths occasionally changing as you go between different ones of these. But otherwise they stay remarkably constant. Let's see. So are there any questions here about IPyWidgets before I switch over to a different plotting library? All right, I'm going to close and halt this notebook. And I'm going to come back and I'm going to open up this notebook called BQ-plot, takes on the data source. So let me show you a couple things first on additional sites here. So BQ-plot is an open source data project. This is the GitHub page for BQ-plot, which has all of the source codes. Very basically, it's a 2D plotting library for Jupyter. And a little more specifically, it's based on the grammar of graphics. So if you aren't familiar with the grammar of graphics, the grammar of graphics is its own conceptual approach to how it is that you generate graphics. With the grammar of graphics, those of you who are familiar with R might be familiar with ggplot2. ggplot is also based on the grammar of graphics. So the idea with the grammar of graphics is you have, we can think about different elements to a graphic, and you generate the entire graphic by building these different pieces on top of each other. That's a little generalized, but the additional feature with BQ-plot is that every component and kind of every layer here that you have on the plot is an interactive widget in itself. So BQ-plot is intended to bring interactivity to the graphics that you generate. So here in my notebook, this I've taken from a GitHub repository from someone here, Chakri Cherukuri, who has a number of different notebooks that you might like to look at. So I encourage you to look at the repository just as a way to see a couple very cool ways to visualize things related to machine learning algorithms and models. This particular notebook also looks at the data source, doesn't. I'll briefly describe what's here, although I don't want it to kind of hit you too much with how much is specified here. A lot of this is just being very specific about what it is that's being plotted and how you organize the data. So here's where you import the BQ plot. It actually has somewhat of a similar API structure to it as what matplotlib does. So here it's assigned the same alias, PLT. The second cell is just specifying the output format for strings. This cell, this imports the data. This is exactly what I had in the other notebook that I just showed you. This generates the summary statistics, which are the mean and the standard deviation and the correlation. And then this is initializing some widget objects, which you can see here. Here, the IPy widgets library is aliased as widgets. So here it's going to generate a dropdown. It's going to generate a box, which I'll point out later. And then very briefly, the top part of this generates the scatter plot. This generates the X and the Y histogram. This specifies that there are no grid lines for the histograms. And then it has an update. So I'll execute this and let's see. So I've execute this one. And by the way, if you get something like this too, which has a little scroll bar to the graphic, you can click on the left-hand side and it'll expand it to a full thing. So here's the drop-down menu. Here's the scatter plot. Here are two histogram plots. And my screen is a little too small, but there's also the mean. If you could see off the left side of this, there would be the statistical values. And it has a neat little feature where as you go between different items on the drop-down menu, this has an animation feature. So the points, kind of flow into each other as it moves from one data set to the next. So that flow, if you look over the code later, you'll see a lot of this is reminiscent of the matplotlib sort of syntax, but it's different enough that it's like speaking a different language dialect. So there are input parameters here which you couldn't use in matplotlib and vice versa. But this animation duration is kind of the input parameter which gives you that flow between different data sets. But basically, here you have a way to structure the widgets that you have. So you have a vertical box, which is the X histogram and the Y histogram. That's this area of the canvas. There's another vertical box, which is the drop down, which is this. It actually extends all the way across this. And then the thing below it is another horizontal box, which is composed of the scatter figure, which is this, the histograms, which is this vertical box here, and then the stats table placeholder, which is just a table, which I'll show you in just a moment what the statistical values are. So this, if you're interested in the specifics of the code, I'd recommend that you look over more specifically the documentation that's on this GitHub page. But I'm going to show you an additional library, which is really nifty too, which is a library called Voila. Voila, as you might guess from the name, is a way to generate something which looks kind of magical, which is it's going to generate an interactive web application from your Jupyter notebook. So Voila is a library to render live Jupyter notebooks that have interactive widgets included in them. So this is another package which I've installed on the Jupyter Hub. It's another Python package. If you come back to this notebook, you'll see there's an icon button up here called Voila. If you click on that, it's going to generate what looks like a web page, which consists of the output and the narrative parts of the notebook I've just showed you. So this is the narrative text up at the top. You may not have been paying too much attention to what output explicitly was being generated, but no output was generated aside from the graphic at the bottom. So there's the narrative text here, and then there's the widget, and this widget, this web page kind of application, I should say, you can interact with it just like you would with an interactive widget inside of the notebook. This does require that you are connected to a Python kernel, so it's not a standalone web page by itself, but it is a way for representing as a web page this application, which doesn't, if you come at this web page, you wouldn't say, oh, well, here's code that's being executed. It's simply a graphic which represents your analytics to whoever's visualizing the web page. So you can come up here and you can play around with it, and it's actually pretty cool. So that's a very nifty library as well. This is just by way of illustration. So there's clearly a lot that you could do with BQ-plot in addition to just generating a graphic like the data source. And just for fun, I've included an additional one. I'll render this here with Voila. Oh no, wait, this is the IPy widgets. I'll render this with Voila again, just to show you an additional feature of BQ-plot. I mentioned that it's, each of the elements is intended to be like a widget in itself. So on these plots now, there are checkboxes which alter what's getting plotted. There's a little button here which you can click on, which will have an effect. But with the graphic itself, you can now have interactivity. So if you come in this and you click on a point, it'll put a point at that place, and it will try and do this Gaussian regression process through that data point. So you can come in here and put in different points. This now is being a little more snazzy. It's not just features external to the plot which are being interactive. You're actually having interactive elements within the plot itself. So this is a very snazzy feature with BQ-plot. And the next library that we're going to go to has some interactive features like this as well. Let me close down these notebooks. The next library I'm going to talk about is Plotly. So this is the one labeled 04, Plotly and Dash take on the Datasaurus. Oh, right. If you've opened up the notebook, please close it back down again. So there's one library that I didn't have time to install on this, since there are a lot of people using the Jupyter Hub and I didn't want to interfere with them. But if you want to interact with this notebook, come back to your file menu, go up to the new button, and open up a new terminal. We have to install something here. So inside of this terminal, I want you to use pip. Oh, that's too big. pip to install Jupyter Dash. So Jupyter Dash is Jupyter, and then an explicit dash character, and then the letters dash. And then hit enter, and this will install a library that we need for that notebook. So if you need that, or I'll just type into the chat that command if you need it. And then once it's installed, you can explicitly exit out of it, or you can just close it for the moment. I'm just going to close it and reorient my screen. So now that I've installed it, this notebook is going to be happier about importing the libraries. So Plotly, let me introduce you to that here too. Plotly is one of the more popular interactive graphing libraries for Python. Plotly itself can actually interact with Python or with R, or it can interact with JavaScript explicitly. As far as Python goes, it's intended to be a way to include JavaScript elements with what you're executing in Python without explicitly having to program the JavaScript part of it. Plotly itself is the name of a company. There's the Plotly library itself, which is an open source graphing library. And then there's an additional project called Dash. Dash is a way to generate a dashboard with Plotly. So we'll come shortly to Dash as well. So we're going to do some initial steps, just importing the library. Plotly, you can kind of think of this a little bit like matplotlib, but like with matplotlib, you can use the pyplot function, which we abbreviated PLT. It's kind of your more high level and somewhat easier to use routines for generating the graphics. With Plotly, Plotly.express has some really easy functions for generating some graphics right off the bat. There's another library called Plotly.graphObjects, which is more low level, and that's like with matplotlib when you use the figure and the axes objects and access the low level objects themselves. You can do something similar with Plotly with the graph objects. For the moment, we're going to use Express. And then this is the same data import command that I had, just assigning the data source doesn't dataset to the dynodf variable. So this is our data source dataset. And then with px, I'm going to call the scatter function. I'm going to pass in the data frame, which is just consisting of the data points that have the data set value equal to dyno. And then in addition to the data we're going to plot, I specify what the x value is, which here is just the values in the x column. And the y values are going to be what's labeled here as the y column. So when I execute this, there's already some interactivity that's built into this. So when you move your mouse on top of the graphic, there's this tooltip which tells you what the x and value is, x and y value are that you're hovering over. You'll see there are a variety of buttons which show up. So these can do a variety of things. For example, if I click on the one that says pan and I click on the graphic and hold my mouse down, I can pan this around. You'll see the axes change, the location of the scattered points change in relation to what's happening with the axes. I can do a selection. So if I click on the box select, I can look at different data points, or I can do a zoom. Let's see, zoom in or zoom out. or I can do an explicit zoom. I can zoom in on this little point. So this is a way to have kind of ready-made interactivity into the graphic itself, just by calling a simple scatterplot function from the library. This just shows that you can pass in different parameters, just like you might pass into the plot function from matplotlib. You can specify, say, what the width and height are. You can specify colors or axes labels and ticks. The Plotly Express library itself is a little more limited than accessing the lower level objects, but you can still do some very fun things, and you can do it very easily and very quickly. So these next cells I'm just going to execute, but this is just going to assign an arbitrary numerical value to each of the data sets. So I'm going to, this is going to be my arbitrary Z, which is a constant value for a given data set, but it varies between data sets. And this is just so that I can show you generating a 3D scatter plot. So now I'm plotting the entire data set where I specify X, the X values for X, the Y column for the Y values, my arbitrary Z now column for the Z values. And I assign a color to the data points depending on what the value is for the data set column. Let me shrink this down. So here now is my 3D graphic. And this now, if I click and hold the mouse button and move the mouse button around, you'll see that there's interactivity built in here to moving the graphic around. So I've done this rather artificially with the data source data set, but you can see the different data sets here in the height, which is the Z value. They have different colors for the different data sets. You know, if you kind of squint your eyes, you can see maybe here's the slanty lines, here's the X ones. Down at the bottom is the Tyrannosaurus Rex. And then you can zoom in on this as well. So there's a lot of cool features that are built in here for you to play around with graphics. Kind of like your own little playground. And then I have a couple of cells here which illustrate how to use the lower level objects. So above we were using Plotly Express. This was plotly.graphObjects, which is commonly abbreviated as Go, or alias as Go. So go.figure generates the figure object. This I'm just generating a smaller data frame just from the DynoDF dataset values that match with Dino. And then to the figure object, I call add trace, and this is how you make a scatter plot. So you call go.scatter with the X and the Y values, and by default, kind of similar to what matplotlib will do, it doesn't generate markers for each of the points. It tries to draw lines between all of the different data points. So you can still see the dinosaur here, but you know, lines aren't what we want. We want to specify more explicitly, not just X and Y, but we want, it's called the mode of this plot to be markers, which are like your scattered data points. And then this specifies characteristics of the markers. So it has to be a dictionary that you assign to this. And then when it specifies the size, a color scale, and the show scale equals true will generate the color scale on the right. So here now is our data source just randomly colored with different color values to show you the features. This is kind of like a whirlwind introduction to Plotly. But now just to show you that you can combine Plotly or actually any other library with the IPy widget library, I'd like you to take what you learned from the IPy widget library. So import that library. Can't remember if I imported that here. So I haven't imported the IPy widgets library yet. You'll have to import that and then try and make it so that you can generate this plot for each of the different data sets with a drop-down menu. All right, so I'll come back and show you here my solution. Hopefully you're starting to get the hang of the IPy widgets library at least. If you come away with nothing but knowing how to use the interact function, you know, that is definitely a good feature to have anyways. I've used this a whole lot in my own work. But here is the code from above, where now I specify explicitly a dataset input parameter rather than an explicitly setting it to Dino. I define the function with the dataset as an input parameter. I imported the IPy widgets library and I called interact with the name of the function, and to the dataset input parameter, I pass in all the unique values of the dataset. So this now will give you the drop-down menu where you can cycle between the different datasets and generate a graph with Plotly for all of these datasets. So I've showed you Plotly, and I mentioned shortly before that Plotly also has the dashboard product. Jupyter Dash is, so Alessandra, in response to your question, let's, I can help you troubleshoot that after the workshop maybe, since that might be an individual thing. Let me go on for the moment to Jupyter Dash. Jupyter Dash, oh, okay, good. That's fine. I'm happy you figured it out. The Jupyter Dash package makes it, its intention is to develop a dashboard web application from Jupyter Notebook and from Plotly, using the two together. I think that the Plotly company realized that there's, you know, a very strong amount of development going on in the Jupyter community, and it was useful to integrate the dashboard application with it. You can use Dash outside of the Jupyter Notebook to explicitly generate web applications from Python code. So it doesn't necessarily have to be integrated with the Jupyter Notebook itself. The Jupyter Dash, which we installed with the pip install, is what was necessary to integrate it into this Jupyter Hub environment that we're working with. So now this is really going to be a whirlwind because we don't you kind of have to build up a lot in order to get something that's, interesting to look at. At the beginning, all we do is, we import the libraries. This specific command is in order to get it to run correctly with the proxy that's running inside of this Jupyter Hub environment. So actually, if you're running these notebooks on your own computer, you might not necessarily have to execute this one. I actually haven't tried it on my own local computer, but we need this in order to visualize this in the Jupyter Hub. And then this is how we create the dashboard application with the Jupyter Dash library. We create a server, which is like the Python web server object. And then to this app, we build on various pieces into it. So this is the HTML div object. This is, if you know HTML code, it kind of helps be familiar with what some of the HTML objects are. This is going to be our title, which is an HTML H1, has the H1 kind of formatting. There's going to be a drop-down menu, and there's going to be a graph. So you have to kind of build in your interactivity into this. So there's a callback which links together your drop-down menu here, which provides the input values, with the graph, which is your output object. What you update as the graph, let's see, how can you, so this, right. So I'm not really covering function decorators at the moment. So don't worry about this if you don't know what a function decorator is, but this is the function decorator. And this is the function which is being decorated. So what this function does is just return the plotly scatter plot object. PX, if you remember, is our alias for plotly express. Scatter was the scatter function. This is the data set that we're generating the scatter plot of, with the X and the Y values. Marginal Y and marginal X will generate the histograms on the side of the scatter plot. And then I specify a width and a height. So when I execute this, no output is generated, but something has been created, which is this server object. And so Flask is like a web server library for Python. You have to explicitly run the server. There are two ways I'm going to show you here. One is if you just pass mode is equal to inline. This kind of, it runs a little local web server inside of the output area inside of the Jupyter Notebook. So this here is the graph object. This is the dropdown, and this is the menu that we specified. This inside of the graph object, now we have our scatter plot, and we have the marginal histograms for Y and for X. And we can come up here and we can change this to illustrate different data sets. You can also run this as a web application unrelated to the output cells inside of the notebook. So if you come and execute this one without the mode equal to inline, hopefully this works correctly for everyone. But it will tell you that now there's a Dash app running on this. And what this is doing is it's proxying the web page that's being generated. If you click on the link there, it should take you to a separate browser tab with that web address, which is the proxy address. And this is your little web server, the web page that's running on that server that you just generated. So you can come and interact this just like we interacted with the widgets, as well as doing various things related to the plotly plot. So you'll see, like when I use plotly express, There's a tooltip here, which tells you the X and the Y values. You have all the little buttons that you can come up here. For example, I could do the pan. You'll notice that the pan for the histogram matches what the pan for the scatter plot is. I can come in here and zoom. Click on this. And it'll zoom in the histograms as well. So we're starting to build up some infrastructure. We're building neat little web applications as well as dashboards. You can make these more sophisticated. So I'm showing you here a more elementary example, which is intended to combine what we did with IPy widgets and matplotlib, say on the one hand, and then we did it with bqplot, and now we're doing it with Plotly and with Dash. This now is could be a standalone web application as long as you had the web server running. I'm going to show you an example from the Jupyter Dash repository, which I've included as a link here. That shows a little more advanced dashboard. Just make sure it executed. And since it's already tied in, one server. Right, so it's linked to the same web page. But here you can see that there are two drop-down menus. There are little buttons here about whether to put it on a linear log scale. And now you have plots that are linked together. So there's a scatter plot. There are two line plots. The line plots are specific trends, say, in each of these variables. One is agriculture, one is life expectancy at birth. And you have a little slider here that you can drag and generate scatter plots at different points, different years. And the tooltip here is not only telling you what those values are, it's altering what's plotted on the right. So there's quite a lot of interactivity that's built in here to this dashboard that's being generated. So yeah, if you're interested in dashboards with Python, definitely worth exploring this in much more detail later. Alt. So I'm going to talk about one final library here, which is Altair. So Altair, I think, is mainly targeted towards statistical visualizations. It's based on Vega and Vega Lite, which Vega and Vega Lite are similar conceptually to what I described before with the grammar of graphics. So Vega is a visualization grammar, which is a specific language for creating, saving, and sharing interactive visualization designs. And Vega Lite, get rid of these controls. Vega Lite, yeah. Vega Lite uses a declarative JSON syntax to create the graphics. So this might be a little more clear, like what that means when we look at this notebook. With the grammar of graphics, I mentioned that you kind of add successive layers onto a graphic as you're building up a graphic. So I'm going to import the Altair library as ALT. And I also import pandas and IPy widgets. And again, since this is a new notebook, I'm going to import the data source dozen dataset, which we are familiar with now. So to generate a plot with Altair, ALT, remember, is the alias for Altair. we kind of build this up in pieces. So the first thing that we call is chart. This is kind of your fundamental graphic object. To chart, we pass in the data that we want to use for that chart, which here is our data frame. Then the method that we call inside of chart specifies what type of graphic we want to generate. So chart says we want to generate the graphic. Mark point tells us we want to generate, in this case, a scatter plot. And then we further call in code on top of that, where we pass in different attributes of the plot. So we're going to tell it what we want to plot for X, and we're going to tell it what we want to plot for Y. And then this entire thing is assigned to the points variable. So I put points here just as a way to generate output after the cell. So here's our dinosaur. It's a scatter plot. You can see it has kind of a nicer little default formatting to it than say matplotlib would just by itself. There's also a thing with 3 dots here, which if I click on this, illustrates the tie-in with Vega and Vega Lite. So if I come down here and I say view source, the source that it's showing me is JSON. And if you aren't familiar with JSON, that's okay. You can think of this as just like a big dictionary, kind of with different levels to the dictionary. So here's a key called datasets. And inside of datasets, I have my own list of data, which has its own dictionary with the dataset value, the X values, and the Y values that are being plotted. So this is the JSON, this is the Vega object. You can see here, kind of this ties in with what you would include on a web page. You can also open this in a Vega editor, which will allow you to view the JSON alongside what would be generated on the web page using this Vega Lite with this particular JSON file. So on this, I can say run, and it generates this graphic, which is how Vega would render the graphic from this JSON file. This is kind of a long-winded way of saying there's a definite tie-in now between the graphic that you're generating inside of a notebook and what you could potentially generate just on the web page by itself. So with the Altair visualizations, we don't necessarily have to have a web server running underneath. This is kind of more closely linked with JavaScript itself, in this case with Vega and Vega Lite. So keep that in mind, and I'll come to that shortly when we try and save one of these. I've showed you how to generate the scatter plot. You can also generate a bar plot. So here I'm calling the similar chart method, but rather than mark points, I call mark bar. So this is going to be a bar plot. And then I tell it for the X. In this case, I want it to be the count of the X values, which this X here refers to the X column of the data set, rather than corresponding with the X here, which is just the horizontal axis. So the horizontal axis corresponds with the count of the X values. The Y value corresponds with the X values inside of the column for the data frame. And then I plot it. Really probably what I want is a histogram rather than a bar plot. So this is relatively spiky, with 1, 2, 3, or 4 values. You can generate a histogram as a bar, but instead of passing in the count, you tell it to bin the values. So this will generate a bar plot. And then you can generate a bar plot similarly for Y. Really what we want to do, might see where I'm going. So I've generated a scat plot and a histogram plot. for X and a histogram plot for Y. And one of these, you can rotate it from being horizontal to being vertical just by how you designate the X and the Y inside of what it is that you're encoding into the plot with these X and Y parameters. So now to plot all of these together, you can use the ampersand with two different plots to plot both of them together. This now is plotting the X histogram and the Y histogram. You can also concatenate plots. So Altair has a method called vconcat, which will vertically concatenate. In this case, I want, say, bar plot for X on top, the scatter plot, and then the vertical plot with Y. So on my top, I have my bars X, and then below that, I have a horizontally concatenated scatter plot, which is points, and bars Y, which is the Y histogram, which gives me my, my plot now of the dinosaur along with the histograms. And then Altair, it's very easy to add interactive elements to this as well. And you do that kind of by adding more pieces on top of what it is you've already constructed. So there's an additional method called the selection interval. So I'm going to create one of these objects and assign it to the variable my underscores si for selection interval. Each of these points, bars X and bars Y, is what I already used for the graphics up here. But now on top of these, I'm going to add additional elements. So in addition to chart.markPoint.encode, I'm going to have a dot something else. And my scatter plot is where I want to select points. So I'm going to add my selection to that to select my underscore SI. And then I'm going to alter the histogram plots based on the selection interval that has been added to the points plot. So I add the selection to the points plot. And then for the bars, for the histogram ones, I call transform filter, and I pass in the same selection interval object for each of them. So for this, you'll see if you drag your mouse over this, a rectangle will pop up. When I stop dragging my mouse, I can go and click on this box and drag it around, actually. So you can go in, you can look at, you just click outside the box to deselect it. So if I wanted to look at those particular points, I draw a little box around them and you can see the histogram of the values. These histograms dynamically change as I'm dragging this. So it might be more useful to more explicitly set, just have a constant range for the Y and X histograms so that they don't, change so much, and it's easier to get a more conceptual idea of the trends. So in this next cell, all I do is I change the scale. This is where you change the scale of, say, in this case, the X, or in this case, the Y. This is another Altair object called the scale, and I change the domain from 0 to 100 for both of them. So now the range here goes from 0 to 100 for both of the histograms, and it doesn't vary as I change this around. But you see now more closely that this histogram matches up with the selection interval. This one matches up with the vertical one here in Y. And you see how they change here. So now we come to one of the final points, which is saving the file. You can call simply, so chart is what I've called here. I've assigned my concatenation of the plots into this chart variable. I call save on it, and then I pass in the name of the file I want to save. When I execute this, it saves an HTML file. And if I come back to my files here, Altosaurus underscore chart HTML. If I click on that, it's going to open up a tab this now is just an HTML page. There's no link here with the kernel for Python on the back end, but I can still have my selection and I can drag it around. And that's because it's translated what I did with Python inside of the notebook into something which is tied in with Vega and Vega Lite and the JSON file. So if I come back here and I click on this breadbox icon and I say edit to look at what's actually inside of the HTML file. I won't assume that you know a whole lot of HTML, but here's where you can see here's where the JavaScript with Vega Lite is linked into this HTML file. This long thing here is the JSON file that I showed you before, which if I come back to the plot inside of here, there's those 3 buttons here, which I can view as the source. This is that JSON file, which was generated for the graphic, which is here inside of the web page that got saved. So this now allows us to generate interactive graphics and widgets without necessarily being linked with the web server on the back end. And so there's a question, what if you emailed this HTML file to someone, will they have to activate the web server before they could view it? No, because where that gets incorporated in here is where you specify the JavaScripts here, which, I mean, you'd have to have access so it could access this online. But this is where the Vega and the Vega Lite are drawn in for it to render what's included here as the Vega JSON file. Yeah, so we're getting it to the end. So I'll just, rather than having this as an exercise for us to go through, you can link Altair. Here I've been, I'll show you briefly. All I did here was I took the code that I used to generate that chart. I put it into a function and I used the interact from IPy widget so that we can generate this now for any of the data sets. Now with this particular one, if we save this as an HTML, because it's linked with IPy widgets, this now would have to be linked to something which is running Python so it could execute the IPy widgets. There's a question of the packages I discussed. Can I cite which of those would allow you to create standalone HTML pages apart from Altair? So actually, I'm not sure if you can do with this. I think none of them do except for Altair. Altair is the only one. Yeah. And then I've included one additional cell here at the bottom, which is, here I'm only plotting X versus Y. Altair is very useful for statistical graphics, and it's useful when you have, more features than just the X and Y location of the plot point. So, let me execute this one. This bottom one shows you a data set which has the categorical value for each of the data points, which is for this particular horsepower of a car and this particular miles per gallon, here's the country of origin for this particular car. So this is illustrated on the Altair website where you can drag, a selection across this. Actually, you see here for the high horsepower and low miles per gallon, it's just in the United States. Which is interesting. But so you can get a nice little sense of the different features of the graphic when you can do, when you can link different graphics together like this and alter how you visualize one part of the data set depending on what you've selected in another graphic. So does Altair do, there's a chat question, does Altair do 3D scatter plots? And that I'm not actually sure about. I would recommend checking out the, let me send you the Altair page here. If you find a 3D scatter plot, I would be interested in seeing it. I'm not sure what it does in the way of 3D graphics. And then just as one final note, I've included one final notebook here for fun, Altair. If you open up this notebook was taken from the GitHub repository for the LA Times data desk. So they've been posting analyses of COVID case data from across the state of California and Los Angeles. If you kind of want to look at a very practical application of Altair, this notebook uses Altair quite extensively to look at the time series history of kind of COVID cases and deaths throughout California and Los Angeles. So if you're interested in looking at Altair, this I think is something that would be interesting to look at as well. There's a question, when you email the HTML file to someone, it seems they have to log into Jupyter. Perhaps we can talk about this afterwards as to what you do, but what I personally would have done is I would click on this button, I'd say download. And then actually, let me see more closely what's inside of the file. If you've actually tested that out, that they have to log into Jupyter, I would guess that there's something in here that links them to Jupyter. But if there's nothing in here that links them specifically to the Jupyter environment, then I wouldn't have thought that you needed access to Jupyter itself. One thing you can do is going a little bit outside of the scope of things, but you can make web pages which you link on the back end to Binder. So what I showed you initially, here's my GitHub. No. Oh, I need my. The Binder service, this one, can be used to link to on the back end, where you have, if you have an actual IPy widget inside of a web page, there are ways to link that widget to linking against a running Binder instant for the Python kernel on the back end. It's oh, let's see. Yeah. So if you have any more questions about it being linked specifically to Jupyter, you're welcome to email me, or any of you are welcome to email me as well. I've come to the end of the class here, so I'm going to stop the recording.